All right, Ken, so making a video to help explain this question. Hope this works. On to slide that has the question. So this question, if 50 pounds of weight is located at point X and 100 pounds is at point Z, how much weight must be located at point Y to balance the plank? All right, so we know Z is 100 pounds and it's located 100 inches from the datum line. All right, we know X is 50 pounds, and that is 50 inches from the datum line. And we know Y is located at 25 inches from the datum line, but we don't know how much it should weigh in order for this to be a balanced teeter-totter. All right, so to figure this out, we want to figure out with that distance and that weight what the acting force is going to be on that side of the teeter-totter. So to figure that out, we're going to multiply the weight times the arm. So weight 100 times arm of 100, and that gives us a total moment, or the acting force at that station, of 10,000. Now, X is 50 pounds, and that's located at 50 inches, and that is going to be a moment of 2,500. And that's measured inch pounds. You're probably familiar with this from like torque specs. So anyways, we want to figure out what Y is. So Y is going to be at 25 inches. So to set up this equation, Y times 25, or 25Y, plus the weight of X times the arm of X is equal to the weight of Z times the arm of Z, which is 10,000, right? So simplifying this equation, Y times 25 plus 2,500 equals 10,000, and we're going to balance this equation by subtracting 2,500 from each side of the equation to zero out this 2,500 here, so that zeros. And then 10,000 minus 2,500 gives us 7,500. So now Y times 25 is equal to 7,500, or a moment of 7,500. Now again, to isolate the term of Y, we're going to divide both sides of the equation by 25. That will turn this 25 here on the left side of the equation into a value of 1. So Y times 1, or 1Y, which is simply just Y, is equal to 7,500 divided by 25. 7,500 divided by 25 will give us a value of 300. So the answer to this question is Y equals 300 pounds. All right. So 300 pounds times 25 will give us a moment of 7,500. That plus the moment of X here, which is 2,500, will give us a total of a 10,000 moment. Or a total moment of 10,000 on the left side of the equation, which would equal the moment of 10,000 on the right side of the teeter-totter, and that is how we figure out the answer to this question. All right, this question ties into the larger concept of weight and balance of an aircraft. So I'm going to give you some homework. Some reading that relates to this question is going to be Chapter 10 of the Pilot's Handbook of Aeronautical Knowledge. So that's I want you to read that section, and I want you to read the Aircraft Weight and Balance Handbook that the FAA publishes. Both of those books are going to introduce you to the terms relative to weight and balance and some of the effects they have on our aircraft. And if you do those readings, when we get a chance, I'm going to go through my weight and balance lesson plan with you and get you understanding some of the forces acting on our aircraft, how weight and balance is important to the safe loading of our aircraft. And yeah, I'm excited to get into this topic until you understand it quite well. All right, thanks for your time, Ken. Talk to you soon. Bye for now.